This lesson is on comparing and ordering fractions, which just means given two or more fractions, make a decision about how they compare in size, such as if you're given 1/3 and 3/5, use the correct symbol to say they're either equal to each other, that one is less than another, or the other one is greater than another. Just a reminder that this means equals. This is the equal symbol, and this is less than and greater than. So let's look at a couple of different kinds of situations that can occur. Probably the simplest situation is when the fractions have the same denominator. If you're comparing 2/7 to 4/7, all you have to do is compare 2 to 4. 2 is less than 4. So 2/7 is less than 4/7. Let's try another example. 6/9 compared to 7/9. Because 6 is less than 7, 6/9 is less than 7/9. The denominator is like a label. If the label is the same, all you have to do is compare the number of things that you have. You have sevenths here, so you have 2/7. Here you have sevenths again, you have 4 of them. Let's try 4/5 compared to 3/5. Because 4 is greater than 3, 4/5 is greater than 3/5. When you compare fractions that have different denominators, sometimes you can use logical reasoning to figure it out. For instance, if you had 2/15 compared to 6/7, you could figure out that 2/15 is pretty close to 0. If this is 0 and this is 1, 2/15 would be, somewhere in this area, just taking a guess. 6/7 is pretty close to 1, maybe right in here somewhere. So it's pretty obvious that 2/15 is less than 6/7. That's easy to see when one fraction is close to 0 and one fraction is close to 1, where 1 is obviously less than a half and 1 is more than a half. But what if they're pretty close together? What if you had something like 3/5 and, say, 4/7? What are we going to do with that? Well, there's a very simple strategy. You say, we know that it's easy to compare fractions when they have the same denominator, so we're just going to find a common denominator for 5ths and 7ths, and then convert these fractions to that to have that denominator. Let me get rid of a little space here, make some more space here. Try it this way. Okay, I want to rewrite that. 3/5 and say what 4/7 is equal to. So we have to think about 5 and 7 and what a common denominator is for 5 and 7. You might notice that these are prime numbers, which means they have no common factors. And if numbers have no common factors, their least common multiple is the product of those numbers. So the least common multiple of 5 and 7 is going to be 5 times 7, which is 35. So we can change 5ths to 35ths. We can change 7ths to 35ths. And I want you to try to recall the name of the property that says you can multiply the numerator and denominator of a fraction by the same number and get an equal fraction. Do you remember what that's called? Hopefully you're thinking the equal fractions property. It's a pretty big deal. So what are we going to multiply 7 by to get 35? And that would be 5. So we have to multiply 4 times 5, and we get 20. What do we multiply 5 by to get 35? And the answer there is 7. So we have to multiply 3 times 7, and we get 21. And they're very close in value. You can see 21 35ths is very close to 20 35ths, but 3/5 is a little bit greater than 4/7. So I'm going to find an empty space up here and just write 3/5 greater than 4/7. So when you have fractions with different denominators, you have to find a common denominator and then compare the numerators. Another situation you might find when you're comparing numbers that involve fractions is when you have mixed numbers. A mixed number is a combination of a whole number along with a fraction. Something, for example, like 3 2/3, where the whole number is 3 and the fraction part is 2/3, or 4 4/7 would be a mixed number, because it has the whole number part and the fraction part. If the whole number parts are different, it's pretty easy. You just compare the whole numbers. So in the case of 3 2/3 and 4 4/7, you would say less than, because 3 is less than 4. If you have a situation where the whole numbers are the same, like 10 and, let's say, 4/15 compared to 10 and 2/3. No, that's too close. Let's make it 2/7. They're pretty close together. They're equal as far as 10 goes. So when you look at the whole number part, you see 10 is the same as 10, so that's sort of tied. So then you have to compare 4/15 to 2/7. In order to do that, we have to find a common denominator for 15ths and 7ths. And when we count by 15s to figure out what's the first one that 7 goes into, we go 15, 30, 45, doesn't work, 60, 7 doesn't go into 60, 75 doesn't work, 90 doesn't work. Then we come to 105, which would actually be the first multiple of 15 that 7 can be divided into. So we would have to convert 15ths to 100/5 and 7ths to 100/5. And if you were keeping track of the way I was counting, I had to count 7 times to get to 105. So 4/15 would be 28 over 105, and we'd have to multiply 7 by 15, and that would give us 30. And sure enough, they're pretty close together, because 30 is pretty close to 28. But 2/7 is greater than 4/15, so 4/15 is less than 2/7. So the correct symbol here would be to say that 10 and 4/15 is less than 10 and 2/7. This was sort of a monster problem, comparing the 4/15 to the 2/7. So let's take a look at the last kind of situation that can occur. It's possible that one or more of the numbers that you're comparing is an improper fraction, or that's in the comparison could be an improper fraction. So you have to remember, if you have something like 26/5, you can think of this fraction bar as being a divided by. So it's the same as 26 divided by 5, which would result in 5 1/5. So we can convert that improper fraction to 5 1/5. So if you had a problem that was comparing 26/5 to 5 2/5, this is kind of easy because I use the same denominator. You would have to convert 26/5 to 5 1/5 and say that's the same as 5 1/5 compared to 5 2/5. So the result would be less than. If we had, let's say, a situation where we wanted to compare, let's say, 18/4 to, I'm going to be pretty close here, 21 over 5. We have to convert both of these improper fractions to mixed numbers, and 18 over 4 would be 4 2/4, which reduces to be the same fraction as 4 1/2. So we'll say that's 4 1/2. 21/5 would be 4 1/5. Now hopefully at this point you can use logical reasonings to know how 1/2 compares to 1/5. And you can think about a number line where you have 0 and 1, and here's a half. This is a half, where does 1/5 fall? Is it between 0 and a half or between a half and 1? And obviously 1/5 would be somewhere in this area. Probably even I probably had that a little close to 0, but it's certainly between 0 and 1/2, so we know that this would be a greater than result. If you wanted to prove it, we could just say the least common denominator of 2 and 5 is 10, and a half is 5/10, and 1/5 is 2/10, and 5 is greater than 2. So that's the proof. So those are the situations you can have. The easiest is if you have the same denominator, you can just compare the numerators. If it's a different denominator, you have to find a common denominator, and then once you write them with the same denominator, you can compare the numerators. Or you might have mixed numbers you have to deal with, or improper fractions that you can convert to mixed numbers.